with our experiment, we're going to play a game called Emotion. So Mr. Evans is going to demonstrate the motions of Earth, and you as a class are going to classify those motions. So what is Mr. Evans doing?
Turning.
He's turning, Lupe?
He's rotating.
Right, Mr. Evan is rotating. So rotation is one of the movements that Earth makes around, What is another motion that Mr. Evan is doing?
Revolving.
Right, Mr. Evan is revolving. So revolution is another motion that the Earth makes around the sun. So today we'll be able to answer the question of the day, which is, what evidence can we gather to demonstrate that Earth rotates on its axis and revolves around the sun?
So we're going to model a couple of directions that we just discussed in the E-motion game. So what am I modeling right now? Which one of the directions was I modeling?
Rotation.
Rotation, right? Which one is this one?
Revolve.
So revolution, right? So those are the two types of things that we're going to talk to you about today. So the next thing is so we're going to pretend that we have just left in a spaceship from Earth, and we're going to look at the Earth from the North Pole. So everyone can see it like this. So what direction is the Earth spinning right now?
Counterclockwise.
Yeah, exactly. So counterclockwise, right? So can someone else come up here and demonstrate rotation? So y'all see this as counterclockwise, spinning that way. But if I look at it from the South Pole, it looks clockwise. So there's two different perspectives that you can see it. So if I'm looking at it from the North Pole, it's counterclockwise. But if I'm looking at it from the South Pole, it's clockwise. But the real way that the Earth spins is actually counterclockwise. Can anyone tell me what this stick is?
The axis.
Exactly, yeah. This is the axis that the Earth spins on. Can someone else come up here and demonstrate it spinning on its axis?
Spinning on its axis. Okay.
So right now, it is spinning on its axis, but an even more accurate representation would be if this down here, at which the Earth is at 66 degrees, or it could be 23 degrees, but we're going to use 66 right now. And this protractor is kept parallel to the ground, and this, the axis, is pointing towards the North Star in the classroom. So now if he spins it counterclockwise, that's a more accurate representation of how the Earth spins on its axis. Okay, so can anyone tell me what this line on the Earth is called?
Equator.
Yes, an equator. So this equator splits the Earth into two hemispheres, northern and southern. So now we're going to pass out job cards. Okay, so the way that the Earth rotates around the sun is actually called an ellipsis, which is more of a circle than it is an oval, but it's not an oval nor a circle. So I'm going to draw the path for you. Okay, so you can see that the path is more of a circular shape rather than an oval shape, but it is not a circle or an oval. So that's the way that the Earth revolves around the sun. So what month would Texas be in during the winter?
December.
Yeah, December. And so what month would it be in during the summer?
July.
July, right. So if it's receiving direct sunlight, it's in the summer, and if it's receiving indirect sunlight, it's in the winter. So now we're going to let y'all do each season and make sure that this protractor is kept parallel to the ground and that the axis is pointing toward the North Star. Okay, so each number represents a season. So if 1 is summer, then that means 2 is going to be fall, 3 is going to be winter, and 4 is going to be spring. So as summer transitions to winter, it's called fall, and when winter transitions to summer, that's called spring. So what we just modeled in the worksheet was Earth's revolution in 365 days. How long is a rotation of Earth one time?
24 hours.
Yes, 24 hours. So on your worksheet, it said how many times does the Earth rotate in one revolution. So if there's 365 days and it rotates one time a day, that means it rotates,
365 times.
yes, 365 times in 1 year.
What changes do we experience as seasons change?
Temperature.
Temperature,
Weather.
weather, is there any more?
The plants change.
Plants change. So what changes do we observe in plants as seasons change?
The plants are greener in the spring and summer.
Plants are greener in the spring and summer. What about in the fall or winter?
They change colors and then
They die with winter. When would you want to plant a garden?
In the summer or spring,
Why wouldn't you want to plant a garden in the winter or fall?
die. It's not as bright, needs sunlight.
Right.
Okay, so to cover up any possible misconceptions, so all areas of the Earth experience seasons, which is false because areas closer to the Earth equator and the poles experience less dramatic seasons because they have very small temperature fluctuations compared to other parts of the Earth. Earth is also at a tilt, so its axis is pointing towards the North Star, so the Earth's axis has not changed throughout its whole revolution. So the Earth's experience the same amount of daylight throughout, which is false because of the poles, because as it spins around the Earth, some of the areas will experience day while others experience night.